Thank you very much. My name is Johannes. I'm stepping in for Martin. Please excuse, he can unfortunately not join, but I hope I'll do my best to explain you our idea on how 3D printed electronics could help a sustainable manufacturing, and perhaps how we as a machine tool manufacturer could support this. So please allow me a first overview on the company right at the beginning. So we are an SME located in Nuremberg, Germany. And we are focusing on building machines for 3D printed electronics. What is 3D printed electronics according to our definition? So we see that we put electronic functionality on a 3D surface, so conformal electronics, as you have seen in the presentations before, or we try to embed it, so bring it into the component. And for that, we have systems that enabling two kind of process routes. We have process route number one. What's the one where we have started with? So with our tools, we want to apply electronics directly onto a 3D surface. The main process steps listed here. Of course, we have this hybrid approach. So we have classical SMT components, bare dies, whatever. Plus, we have the option to use printing processes, mainly writing processes, to apply electrical functional materials to, for example, create conductive lines and interconnector components. For placing the components, of course, the pick and place and what needs to be integrated as well from our point of view. In particular, if you want to embed, you need to check the pre and post processes that are required for the inks. The second route for us is that with, let's say, the rise of the additive manufacturing and the technologies and the maturity that they have, we were thinking, okay, we can use the tools that we have, not just to print onto a surface, but also try to embed it, what makes it more robust, for example. So this is the route number two, where we can also additively manufacture the substrate or use additively manufactured substrates coming from an external source. So what are our systems all about? So basically, we are a system integrator. This means we are using a CNC platform. We are really focusing on 3D processing, not planar processes. So we are using CNCs with additional axis, rotational axis. We are using a software tool that enables to program this with the appropriate interfaces. And we, of course, integrate according to the application different kind of print modules coming from jetting, piezo jetting, aerosol-based processes like we have seen from Optomec. We have a similar one from IDS. They have a booth outside, inkjetting processes, and of course the pick and place as mentioned, plus some pre and post treatment. We have seen a presentation about laser curing and laser ablation, a very promising tool from our point of view. But of course we need something like plasma treatment or UV or infrared as well. So this is what we combine. We try to integrate it. In particular, the focus is on the software, having a software package that enables the operator to handle all these different processes and helps to design his product. So let me give an example quite similar to what we have seen before. So we have here a medical application coming out from a research project called AMT. And here we have some ASIC bare dies placed on a ring. The ring is has a diameter of around about 6 millimeters. And we need to interconnect these and we need to apply a coating for that. And the benefit, of course, should be that this assembly steps needs to be reduced. And we have here a benefit that we cannot use a system that's placed on a film. That was the request from our customer. Let me show a video short to see the assembly process.